begins out here on the tipping floor, where bottles, cans, and paper are dropped off by the truckload. Powerful loaders then push all this stuff onto one conveyor belt leading to the main facility where the sorting process begins. First, the big things get pulled out at the first pre-sort, or what I like to call the big bad thing remover. These quick-handed people go through all this and pull out larger bad things that are very damaging to the recycling system, full of state-of-the-art equipment that takes in recyclable materials all mixed together from your homes, schools, and businesses. The materials are then sorted, screened, shaken, and baled so they can be resold and made into new products. So put on your hard hats. All of us together. It's called single-stream recycling, and it's so simple, everyone can take part in helping the planet.
Every day we use these buttons. But do you know how these are manufactured? The answer is compression molding. Let us see the advantages of compression molding. It requires relatively low capital and tooling cost, low mold maintenance. The product has low residual stress, and products retains mechanical and electrical properties. However, it has some disadvantages also. It is not economical for making a small number of parts. That means once the molds are manufactured, it should be used for large number of parts of same size. Compression molding involves molding of molten plastic through compression. Let us understand the process of compression molding. It consists of two parts, upper part of the die and lower part of the die. The lower part of the die is fixed and upper part of the die is movable through guide pins. Lower part of the die has the facility of heating as well as cooling. Predetermined quantities of plastic materials, that is nothing but resins, fillers, reinforcements, plasticizers, lubricants, stabilizers, fire retardants, colorants, which are nothing but the additives of the plastic material, are taken into the mold cavity. Then the two halves are closed by applying the pressure. Here the pressure is about 100 to 500 kg per centimeter square, and then the article is heated. Finally, the curing is done. Curing means heating in the case of thermosetting polymers and cooling in the case of thermoplastic polymers. This is because in case of thermoplastic polymers, it is just an addition polymerization and it is a exothermic reaction. Hence, to take the reaction into the forward direction, we need cooling. Finally, with the help of extraction pin, the molds are opened and the article is taken out. We can make shades of plastic, crockeries, 3-pin mains plug, or electrical switches which are made up of bakelite, which is nothing but a thermosetting polymer, bumpers of car, handles of electric iron or cooker, plastic boots, toys.
Nobody else in the business. As the glass moves through the machine, special cameras watch. Light beams are shot at the glass, and the camera can tell if the light goes through the glass. If it doesn't, a computer connected to the KSP knows the material is not glass and that it must be removed. The computer signals air jets to push the non-glass material into a storage bin and later transported to bottle manufacturers.
Out of 4 different parts. We have the shredding part, the power supply, the framework and the hopper. And we're going to start off making the shredders. And this is by far the most complex part of this machine. So here we have the core elements of the shredder machine. And you can download a package with all the drawings from our website. And you can just send them to a laser cutter, plasma cutter or water cutter. And they will cut out all the parts, like the blades, the spacers, the side plates. So here we have the X for the shredder, and we're gonna put on the blades. And we're going to add a spacer, then we're going to add blade number 2 and blade 3. In this way we have a nice cutting flow for the shredder, but feel free to play around and use different configurations. So everything is connected, make sure everything works. And then we're gonna tighten it up and weld these metal plates together. And then it should be rock solid. Here we have the mesh that goes under the shredder. Size of this mesh determines the output you want. So if you have different mesh, you will have bigger or smaller flakes. We're gonna weld the mesh onto these 2 holders. And then we can put this one under the shredder. We painted these bars on the shredder and we tightened everything. Make sure to take your time to do this because you want to make it go completely smooth. That you can hear this.
Nothing.
Exactly nothing. So we just finished the shredder part and now we're going to focus on the power supply. And it's pretty straightforward, but there are some key things to watch out for. Let you do it. Sorry. So here we have our beautiful engine. It doesn't really matter how it looks or how big it is or the size. We only need to make sure it's slow and powerful. And right now we need to attach the motor to the shredder so it will turn around. And maybe we'll give it a paint job. So now we're going to wire everything up, and we found a great place to get your second-hand cables. We're currently at the junkyard, and this is a great place to find cables to connect all the electronics, and they have plenty of them. And usually we're going to connect all the electronics in a metal box. However, today we found this little guy. We want to connect all the electronics inside this one. All the electronics are inside this jerry can, and we installed a switch here so we can make the motor go both directions. Now we're going to hook it up to the framework and shred some plastic. We finished up the shredder and the power supply, and now we're going to focus on the framework. And since there's a lot of force and strength going on in here, we need to make sure the framework is rock solid. Yep. So since our motor is slightly bigger than our cutting, we had to fill this gap. So use our blueprints as a reference since you probably have a different engine. Just make sure that it's perfectly aligned from the power to the cutting. Let me show you. We're almost ready, and we finished up the shredder, the power supply and the framework. But last but not least, we need to make the hopper. And this is where the plastic waste goes into the machine. The hopper is made from sheet metal, and there are different ways how to get sheet metal. Today we're going to use this one from an old truck. We're going to cut it out, weld it together, and then we have the hopper. Finally the hopper, and now it is ready. Next we're going to show you how this little switch, and you can make it turn both ways, so if plastic gets stuck or something like that you can turn it the other way around, and the plastic waste goes into the hopper, and then it will be shredded. So let's shred some plastic. The output of the shredder is still pretty big. That's why you can also add a mesh underneath. And the size of the mesh determines the output. Connect this one under here with a few screws, and then we'll show you the difference. As you can see, there's a big difference between shredded plastic without the mesh and with the mesh. Do note that the smaller you want your plastic to be, the more energy and the longer it takes. You can play around with this, like sorting out different colors or going really small or get bigger plates.
Cardboard is made by sandwiching a corrugated sheet of paper between inner and outer paper liners. Sealing board has a center of gypsum and outer linings of paper. The recycling of materials has become very important for maintaining a green world. The bales of raw materials are dropped into a machine known as a MacPulper or pot. Here the materials are mixed with water. Cardboard is broken down into a paste and foreign materials such as plastics and metals are removed. The material moves through a number of stages where it is dried while being pressed and worked to get it to the right consistency. This material, which is known as the noodle in the industry, is stored, ready to be fed to the paper-making machines when required.
It is then cut up into homogeneous sized batches in order to be shipped in bulk or in packets and sold either in its country of origin or internationally. The group now has over 70 sites in Europe and Asia and a network of sales engineers who are experts in trading these materials on world markets. It is the result of high technology sorting of non-ferrous residues from the group's industrial shredders. Our long-standing expertise in this area, which has set a benchmark for the industry, has developed considerably since 2011. A new sorting unit for shredder residues has been installed in place of the old one, an investment of over 17 million euros. The new system presents a double advantage: more efficient shredding and a regular supply of a range of non-ferrous metals which are homogeneously sorted. All these non-ferrous metals, scrap metal from individuals and businesses, offcuts from manufacturing, and shredding residues, will be recycled as new high-quality secondary raw materials. The group, via its trading operations, buys and sells several 100,000 tons of non-ferrous metal every year, all over the world. The prices of these metals are constantly fluctuating according to world market prices. The official market quotation is determined by the London Metal Exchange, or LME. Ecor Trading bases its buying and selling prices on this quotation. On these markets, which can be very volatile, risk management is essential in order to ensure the success of any transaction. To this end, the Ecor Group covers its fixed margin transactions by hedging its operations on the LME, so that the prices are guaranteed and the transaction is secure. Includes packing the materials and guaranteeing their quality, while meeting high environmental and safety standards.
At Metro Vancouver's waste-to-energy facility, a 5-story tall structure has been added to the side of the building. It contains electromagnetic technology that can separate valuable metals from the bottom ash. Bottom ash is the residue of the waste combustion process. It's the ash that falls to the bottom after waste is incinerated. The bottom ash is cooled and conveyed to bunkers. Then, magnetic metals, also known as ferrous metals, like iron, are routinely removed by passing under a magnetic extractor. Also in 2018, the extraction of non-ferrous metals from bottom ash began. Non-ferrous metals include valuable materials like aluminum and copper. A device called an eddy current separator sends an electric current through the passing load. Non-ferrous metals are briefly magnetized so that they are repelled and fly into a separated area at the back end of the chute. The remaining reduced amounts of bottom ash used in cost-saving and beneficial applications, such as replacing aggregate materials as building foundation in Metro Vancouver projects.